Howdy out there in CNC machining land. I got these cool little blaster, tiny. You know, there wasn't much coolant in here. Maybe for my tabletop mill. No, this is actually I ordered some more shirts from Titan and Shani. I love her. She put a couple of these in here. These have been good. I've actually been putting them on near the machines to put like the tools, like or drills. You know, the ones stuff we use all the time. So it's pretty cool. And here I'm going to use it as a pen holder. So excellent. Thanks. Okay, if you go, and I decided to put my view up in the upper corner. I saw I've been hiding a lot of clicks on here, and I don't see it when I'm working away here. I did not design or set this thing up. If you go into Fusion and go into CAM samples, they're all in there. A lot of demos. Haas demos. There's a bottle opener there. It's got, oops, oh, I'm in the way again, sorry. Fly over here. Okay, the bottle opener, there's a 4-axis part, which I have right here. Oops, let me unzoom this. Oh, I think I got some things shut off here. Models. Yes, I do. Oh, I got a lot of things shut off. I haven't opened this up in a while, but I think I was doing a lesson on the horizontal mill. So this one over here is right here. This is a tombstone for a horizontal mill. And as soon as it comes up, I actually noticed on here that it made a part that I was very familiar with. These are the blocks that go on a Haas ST10. So these are vertical vices here. So they got it set up to do 2 operations, and I can see that, you know, when you're trying to design parts, you design them so in manufacturing, so they're able to machine this in 2 operations. And here's the material here. So the upper row looks like operation 1, and the bottom one looks like operation 2. It's got a Jurgens plate on the bottom, tombstone. Okay, so there's a bunch of stuff in here. CAM samples, work holding, 2D milling patterns, a chess pawn, 3D, 4-axis. I think there's some 5 here. Intro to 3+2 milling, mill turn. So in this one, we have a Haas rotary on our VF2. We have it actually called a 5C. It's very small. But right here, this is, and actually I learned how to do the Fusion 4-axis by just looking at this video. And actually I hid the spacer. We're trying to make, this is a Raptor mount, so you can upload the Raptor mount. You can actually upload the rotary table and this table, but you can get these all from Haas. With your Kurt vices, everything you can get from there. So let me hide my view selections, models, setup. So I'm going to have a couple of these shut off here. That looks like a, oh, this must be the vice for operation 2. So we get, shut that off. Raptor setup. Right there, not that one. Yeah, this is the spacer plate. I see right there, that's the Raptor part number. So this is an adapter to the, I don't know if this is a 160 rotary. So it matches that bolt pattern. And this is an adapter for the adapter, right? And this is a nice mounting system. You have to pre-machine this dovetail. And if you look at the material, a round chunk of material with the little dovetail, that's how we're going to hold it. So I think 4-axis is a real nice way on the journey to multi-axis. So did I hide everything again? Okay, right there. Okay, let me double click, resume this. So you got a table. You can put the whole machine in if you want, but it says right there, no, Haas rotary table 210, right? What's this? What is demo and table? Table off, table on. So it's typically, I had to turn this around. Most people put the rotary table on the right side, and this faces left. This will be the A axis. Now when you get a B axis, like a double table, it's like A goes around, A goes around X, and it's either the other one's going to be B or C. You don't need 6 axis because the table can go in X and Y and go in circles. You don't really need a 6th. C technically is in line with Z, but all right. So in this one, this is the part right here. Let's just shut off all the other stuff there, and all that. So and see all the bolts. All right, got floating bolts. Anyway, looks like they have the. Let's see. Raptor setup. Is the? Oh, that's the other side. Sorry. Sketches, construction, planes, bodies, joints, ridges, sketches. All right. Anyway, I'm trying to figure out. They must have drawn the material and made it translucent. That's what I've been doing lately, just to get a visual on it. So it's not really the material from the setup, or is it? Right. So I go into here, edit the setup, right? I said, oh, yeah, the material is from solid, so it's already designed. Okay, so setup is, and typically with 4-axis, you're going to put the Z and Y right in the middle. And X can be anywhere. Like if you were to set this up and made it X is the front of the material, or X is a little bit shifted to the right. So that'd be model alignment versus stock alignment. So in order to get, I should just shut those bolts off. You would, what I do is I do the web probe to probe both sides to find the middle. And then once I find the middle, I am right over the top, and I probe the top because that's the highest part of the hill. And then I just shift it down to the center, to whatever the diameter of the material is. Some people use the table as a reference. Let me put the table back. Because when they build these, this center line of this is like a known distance. I've seen it done that way. Or they'll make a block here that's exactly the height of the center line. So I've seen it done that way. All right. Let me turn on the... So we're trying to make our own Raptor. We don't have as much money. So we already made this part. And we're making something like this, but we're going to use Mighty Bite clamps. We're trying to get away with not dovetailing. Let's see if it works. All right, let's just simulate this thing. It's supposed to be done, right? All right, let me double click. Let me pull this out of the way. Shut off the setup. Oops. All right, so I made some more views because I kept on flipping back to that view, and I wanted it to be in the that view there. So I can save more views, just put new updated view. Okay, let's hit rotary op setup. Okay, simulate. So if this was turned on the lathe, then we're only need to mill features. We wouldn't. It'd probably be best. It would actually look better. And you're just going to mill the features. All right. So we press play. All right. For right now, I made my tool transparent. I leave the tool paths off. So you can see what's going on there, right? Oh, it's milling that flat area. Okay, and it rotates. Funny thing about simulation in CAD CAM is, in reality, the part is turning, but in CAD CAM, it's the tool turning. So just how it's simulation is not exactly the same. And I have this set up to be colorization by operation. So that's another operation there. So something about that side must be slightly different. I think there's 3 green sides and 3 purple sides. So these are all, looks like face milling. It'll be indexing. All right, I'm going to pause this. If you hit this button, you can go operation at a time. Operation, operation. Okay. So what I liked about this was like, oh, how did I get the rotational stuff, right? So I turn this on. Tool 171. Well, I'll have to edit that. So, all right. So I went in here, and I'm looking at this, I'm going, all right, this is pretty typical, 7,000 RPM, geometry. Oh, tool orientation is now checked. That's never checked on the other ones. Is there anything different on the initial setup, right? No, that's new setup, edit. So this is all the same. This is all the same. And this is the same. Okay. Nothing special there. Nope. It says fixture. You can actually turn on the fixture and you can make it so I can identify it so for collision detection. All right. Back to here. Edit. This is pretty standard. This isn't. So right here is tool orientation. So what you need to do is align your Z and X the way it would be in when you go to machine that way. So looks like in this case they just rotated it around the X. How do we do that? It looks like you select some of these. So it says select axis and plane. And from origin, so what are your selectors here? Model, select, okay. And retract type. So, got stock top, model top, feed height disabled, top height, retract height. Okay. And all this is pretty standard stuff. Okay, I don't see anything. And there's the toolpath right there. Toolpath for one operation. So, I don't see them all. How come we don't have them all? Because down here it says circular. What's that mean? Oh, look at that. More stuff. Let me go this one. Okay, let me shut that one off. Turn this one on. Okay, we got that feature. That feature. That's the bottom. What's this one? Adaptive. So that's different. So how does it rotate, right? Oh, here, right here it says wrap pattern. Pattern. So pattern, you can get it to do repetitive stuff. Like in a flat place, or in this case, in a rotary. So you can program each one individually, but if there's nothing that changes other than position. Like, all right, so these two operations are different from each other. So you would need to rotate this one 120 degrees twice. All right, how does it do that in here? Wrapped features. I see 2D adaptive. So these are roughing. This is face mill. This is adaptive and contour. So this is like twosies. And that's all there is. So up here in settings, flat features, wrapped features. The wrapped is actually doing the curve. These are what we call 3+1 milling. You're indexing. You're just turning and indexing. These are full 4-axis because it has to turn the A while it's doing that. So the feed rate actually becomes different because a rotary axis is not linear, it's not a line. So it's I think it's called inverse feed time. It's it's a little slightly different. And there are some settings on a Haas that they'll ask you the diameter of your object because it has to like do another calculation to convert like round into linear. But I can see right here, these are ramping moves in and like a cone, and these are the machining paths right there. Looks like adaptive machining paths. So let's break this down a little bit more. So I got face, and this says wrap pattern. So let's see. Trying to learn this backwards. This is all under models. So wrapped features, wrap pattern. So I'm trying to figure out here. I thought there was a, let's see. Let's go into here again. Edit. All right, so we got geometry, tool selections, and so it identifies the stock. Yeah. Yep. Tool heights, multiple depths. Okay. And that. So trying to figure out. Let's just let this run. We'll do some thinking here. Simulate. All right. Press play. There's a little dovetail there. All right. So mills to flat. All right, let's finish doing that. That's a finish of like. So then they flip to this one, right? That one's different. That one we know. It goes back to that with a different orientation. Let me make this solid. Ooh. There we go. Last time I did this, I thought it was very obvious how the wrapped worked, how the pattern, I think it's pattern. All right, let's bail out of this. Close. So up here, you got setup and new pattern. Duplicates a single toolpath instance that can be used for multiple instances in the same part. Pattern. So this is wrap pattern up here, right? But these are all, these are named views, right? Oh, this is actually, these are my name views, and these are pot on rotary feature video screenshot. Okay. Origin, that's pretty straightforward. Bodies, sketches, construction. No, that's that other vice. Oh, I am baffled. Is everything? Oh, wait a minute. It says flat features circular. Let me edit this one. Pattern. Here it is, right here. All right, so you set up the pattern to begin with. So everything under this is going to be following the patterning. Post-process override work coordinate. Okay. Axis is the face. Okay. Angle 360. Number of instances 3. Keep original equal spacing. Order by tool. Meaning that don't go 1, 2, 3. Keep on changing tools. Just keep the tool out. And do as much as you can, because yeah, that would definitely save time. Okay, so this is where the patterning comes in. So up here is the same thing. Hit cancel and edit. Same thing, pattern. The pattern leads you to the other operations. So you gotta put a well, I think you can do one operation and and then sneak a pattern in before that. So anyway, personally, I'm going to play around with this a little bit because we're going to finish. We actually our 4-axis, I'm sorry, 5C rotary. We have collets. We have some bigger collets, and we have a 3-jaw chuck. That's a screw-on chuck. So we can do something like this and just hold it with the chuck and see if it holds well. I mean, the Raptor dovetail is a very good system. Or we had something like those 5-axis self-centering vices, but we don't have the money for that. So we just try to learn this stuff. We actually had made a titanium golf club putter head, and that took about 4 or 5 operations. And then we realized, wow, if we had put it in this orientation, we could have done like 3 of the operations in one fell swoop, and then held it in the soft jaws and just cut the back off. So trying to think out of the box here. Anyway, 4-axis. I love multi-axis. Talk to you later.